Hello students, welcome back to another session of maths class. In our previous sessions, we have studied about some concepts of congruence of triangles and we have completed exercise 7.2. Today, we are going to study about some more concepts of congruence of triangles. So students, let us go through the concepts, okay? So, as you can see, I have constructed two triangles as it is given in your book. Both the triangles have sides 4.5 centimeter, 4 centimeter and 3.5 centimeter. Okay. So the triangles, they are in some other direction. The directions of the triangle are different from each other, but the sides, they are equal. So when I rotate the triangle, okay, when I rotate the triangle and place one triangle over another, then we can see that both the triangles, they coincide with each other. Okay. So in that case, we can say that they are congruent. Okay, they are congruent. We can do it by drawing the triangles on a piece of paper, cut it out and we can place one over other and we can see they are coinciding with each other, and we can repeat this activity with some more triangles. So in that case, we arrive at another rule for congruency. Okay, which all things are given over here? No angles, only sides. No angles, only sides. So we can come to the rule of congruence: side, side and side. So we can say that two triangles are congruent when the corresponding sides are equal to each other. All the corresponding sides. It can't be true if the corresponding sides are not equal to each other. It will be only true when the corresponding sides will be equal to each other. So that gives us another rule for congruency. Okay. So what theorem 7.4 says? That is SSS congruence rule. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. This theorem can be proved using a suitable construction. So students, you have already seen that in the SAS congruence rule, the pair of equal angles has to be the included angle between the pairs of corresponding pair of equal sides. And if this is not so, the two triangles may not be congruent. Let us perform this activity. Let us construct two right angle triangles with hypotenuse equal to 5 centimeter and one side equal to 4 centimeter each. So let me draw the diagram first. So students, you can see two right angle triangles, they are opposite in direction to each other. Both have base as 4 centimeter and hypotenuse 5 centimeter. Okay. If you draw these right angles in a paper and cut them out and place one triangle over the other with equal sides placed on each other, then you can see that both the triangles will coincide with each other. See, if I turn it from here like this, or if I turn this triangle like this, so as hypotenuse is of same length and base is of same length, now this triangle, when it is turned around, will coincide with this triangle, or either way, this triangle when turned around like this and placed over this triangle, it will coincide with this triangle. The two triangles cover each other completely and so they are congruent. We can repeat this activity with other pairs of right triangles and we will observe the same thing. If we have any of the sides, either hypotenuse or base, of different lengths, then we can observe that they will not coincide with each other. That means those triangles are not congruent. So we will find that two right angles are congruent if one pair of sides and the hypotenuse are equal. Okay. We have verified this in earlier classes, isn't it? So, note that the right angle is not the included angle in this case. That means, see, what we have observed in case of SAS congruency says that the angle has to be the included angle, and in this case the included angle between the hypotenuse and the base is this one. This is the included angle. In the same way, here this is the included angle, but the included angle values are not given, but the angle that is not included angle is a right angle. So in this case also both the triangles can be congruent. So it's not necessary that the included angle is given or not. That means we arrive at the following congruence rule, that is theorem 7.5 RHS congruency, that is right angle, hypotenuse and side congruence rule. What it says? It says if in two right triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. And we have to note that RHS stands for right angle, hypotenuse, side. Let us now take some examples. Okay. So students, let us discuss example 7. It says AB is a line segment, P and Q are points on opposite sides of AB such that each of them is equidistant from the point A and B. Show that the line PQ is the perpendicular bisector of AB. The diagram is given in your book, that is figure 7.37. Let me draw the diagram first, then we will go for the solution. Okay. So students, as it is given in your diagram, I have drawn the same diagram over here. So what is it given? It is given that PA is equal to PB, PA is equal to PB, QA is equal to QB, and we have to show that PQ is perpendicular to AB and PQ bisects AB. Okay. What we have to show? To show PQ is perpendicular to AB, PQ bisects AB. So let us say that PQ intersect AB at C. So let this point be C. PQ intersects AB at C. Let us take triangle PAQ and PBQ. Triangle PAQ, we have taken triangle PAQ and triangle PBQ. In these two triangles, what data we have? We have AP is equal to, okay, PB, AQ is equal to BQ, right? PQ is PQ, that is common. This is common, and these two data are given, isn't it? We have three sides or three corresponding sides, they are equal to each other. Therefore, that implies triangle PAQ is congruent to triangle PBQ. Why? SSS congruency. So these two triangles are congruent following the SSS congruency. And let us now consider triangle PAC and triangle PBC. Before that, as PAQ and PBQ, these two triangles are congruent, what else we can find, or what else we have got, that angle APQ and angle BPQ, angle APQ and BPQ, that implies angle APQ is equal to angle BPQ. Why? Corresponding parts. Okay. So now let us consider triangle PAC and triangle PBC and check whether they are congruent or not. Okay. So let us consider triangle PAC and triangle PBC. Triangle PAC and triangle PBC. In this triangle, what data we have? We have AP is equal to BP, it is given. Fine. Angle APC is equal to angle BPC. Angle APC is equal to angle BPC. It is already proved. Fine. And PC is equal to PC. PC is equal to PC. Why? Common. They are common sides. That means we have two corresponding sides and one angle. They are equal to each other. But whether these two angles are included angle for these two sides, let us check. AP and PC and angle APC. Fine. This is included angle. PC and PB and angle BPC. Fine. This is also included angle. That means triangle PAC is congruent to triangle PBC by SAS congruency. So these two triangles are congruent following SAS congruency. Fine. So as they are congruent, another thing we can see that AC is equal to BC. That implies AC is equal to BC. Why? They are corresponding parts. Okay. So they are corresponding. Another thing we can find out that angle ACP is equal to angle BCP. Angle ACP is equal to angle BCP. They are also corresponding parts. Fine. Now let us go ahead with the solution part. Okay. So students, we can also see that angle ACP and angle BCP, they are linear pair, isn't it? Angle ACP and angle BCP. That implies angle ACP plus angle BCP is equal to 180 degree. Why? Because they are linear pair. They are linear pair. We know that linear pair are the angles which are or which lie on a straight line. They are pair of angles which lie on a straight line. That means their values sum up to 180 degree. Okay. So that implies two angle ACP is equal to 180 degree. Why I have written that 2 angle ACP is equal to 180 degree? Because we have already proved that angle ACP is equal to angle BCP. So as both the angles have the same value, so I can write 2 ACP, that is ACP plus ACP. 2 ACP is equal to 180 degree, or that implies angle ACP is equal to 180 degree divided by 2, that is 90 degree. 90 degree. Okay. So students, what we have found that AC is equal to BC and ACP is a right angle. So from these two we can easily conclude that PQ is the perpendicular bisector of AB. What is a perpendicular bisector? Perpendicular bisector is a line perpendicular to another line which bisects the other line. That means in this case PC is perpendicular to AB. Fine. AC is equal to BC. That means C is the midpoint of AB. And when we extend PC, it reaches to Q. That means this PQ is a line segment which is bisecting AB perpendicularly at point C. So hence PQ is the perpendicular bisector of AB. Okay. I am saying it again, as these two triangles are congruent, AC is equal to BC. We have also proved that angle ACP is a right angle. That means C is the midpoint of AB. When I extend PC, it reaches Q. So PQ is the line segment which is bisecting AB at point C, and as ACP is 90 degree, that means PQ is the perpendicular bisector of AB. So students, we can note that without showing the congruence of triangle PAQ and triangle PBQ, you cannot show that triangle PAC is congruent to triangle PBC, even though AP is equal to BP, PC is equal to PC, and angle PAC is equal to angle PBC. So in this case, what is happening? Let us see. AP is equal to BP. It is given. Then PC is equal to PC. It is common. And angle PAC is equal to angle PBC. Okay. That why? Because angles opposite to equal sides of triangle APB. Exactly, triangle APB. But in this case, we have two sides, another angle. Let us check whether these angles are included angles of those triangles or not. AP and PC. Okay, AP, PC and PAC. So this angle is not the included angle for AP and PC. So we cannot go for SAS rule of congruency. It is giving us SSA rule of congruency, which is not always valid or true. That's why the angle is not included between the equal pairs of sides. Okay, the angle is not included between the equal pairs of side, we cannot go for the congruency of those triangles. Okay. Students, let us now discuss example 8. Okay. What it says? It says P is a point equidistant from two lines L and M intersecting at point A. You can see it in figure 7.38. Show that the line AP bisects the angle between them. So let me draw the diagram first, then we will go for the solution. Okay. Students, now we have two lines L and M which intersect each other at A. It is given in your book as well, and I have constructed the same diagram over here. Okay. Line L and M, they are intersecting at point A. Okay. Now let PB is perpendicular to L. Which one? P and B. PB is perpendicular to L and PC is perpendicular to M. And it is given that PB is equal to PC. Fine. So PB is perpendicular to L, PC is perpendicular to M, and PB is equal to PC. This is given. Fine. Now we have to show that angle PAB is equal to angle PAC. To show angle PAB is equal to angle PAC. Okay. So let us go ahead. Students, let us consider triangle PAB and triangle PAC. So in triangle PAB and triangle PAC, what we have got? We have PB is equal to PC. PB is equal to PC, it is given. Fine. Angle PBA is equal to angle PCA. Angle PBA is equal to angle PCA. Why? That is 90 degree. Okay, it is also given. Then PA is equal to PA. PA is equal to PA. It's common. So, PA, PB and a right angle, that means we can go for the RHS rule of congruency. That's why it is implied that triangle PAB is congruent to triangle PAC by RHS congruency. Fine. Now, as triangle PAB is congruent to triangle PAC, angle PAB is equal to angle PAC. Angle PAB is equal to angle PAC. So, as triangle PAB is congruent to triangle PAC, angle PAB is equal to angle PAC. Why? CP, CT. So, we can note that this result is the converse of the result proved in question 5 of exercise 7.1. You can refer question 5 of exercise 7.1 and you can find that this is just the converse of that particular question. Okay? Students, hope you understood these two examples. Now, we will go for the exercise, that is exercise 7.3. Okay? So, students, let us discuss exercise 7.3. First question says, triangle ABC and triangle DBC are two isosceles triangles on the same base BC and vertices A and D are on the same side of BC. You can see figure 7.39. If AD is extended to intersect BC at P, show that triangle ABD is congruent to triangle ACD, triangle ABP is congruent to triangle ACP, AP bisects angle A as well as angle D, and AP is the perpendicular bisector of BC. So, we need to prove all these things. So, let me draw the diagram first, then we will go for the solution. Okay? So, students, as it is given in your book, I have drawn the same diagram over here. Now, let us discuss the solution. Bit 1. Okay. Let us now consider triangle ABD and triangle ACD. Okay. So, in these two triangles, AB is equal to AC. Okay. It is your given. Then what else? BD is equal to CD. It is also given. Fine. BD is equal to CD, it is given. Another thing, that is your AD is equal to DA. AD is equal to DA, those are common sides. AD is equal to DA, common. Now, from these three, what we have got? We have three sides, those are equal to each other. That implies triangle ABD and triangle ACD are congruent following the SSS rule of congruency. So, triangle ABD is congruent to triangle ACD by SSS rule of congruency. Okay? So, that implies, because these two triangles are now congruent, that means angle BAD is equal to angle CAD and angle ABD is equal to angle ACD. Why? Those are corresponding parts. Fine. So, bit 1 is now clear. Hope you have understood. So, let us consider triangle ABP and ACP. Let us consider triangle ABP and triangle ACP. Fine. What we have? We have AB is equal to AC. It is given. Fine. Then AP is equal to PA. Those are common sides. So, common, and angle BAP is equal to angle CAP. Angle BAP is equal to angle CAP. Angle BAP is equal to angle CAP. Why? It is already proved. Fine. So, from here, let us check. AB is equal to AC. Fine. AB is equal to AC. And AP is equal to PA. AP is equal to PA because it is common. Now, BAP is equal to CAP. BAP is equal to CAP. That means these are the included angles. That means triangle ABP is congruent to triangle ACP by SAS rule. By SSS rule. So, it also implies BP is equal to PC. Okay, BP is equal to PC, as these two are congruent now. So, you can write BP is equal to PC as well as angle BPA is equal to angle CPA. Angle CPA. Why? This is the result of the congruency. Okay. So, BP is equal to PC and angle BPA is equal to angle CPA. Fine. So, let us discuss bit number 3. Okay. From bit number 2, okay, we have angle BAP is equal to angle CAP. Fine. Angle BAP is equal to angle CAP. That means it implies AP bisects angle A. AP bisects angle A. Because these two angles are equal, that means AP bisects angle A. It's obvious, isn't it? Also, what we have got? Angle BAD plus angle ABD. Angle BAD and angle ABD is equal to angle CAD. Angle CAD. Angle BAD plus angle ABD is equal to angle CAD, or it is also equal to angle ACD, which we have already proved. That implies angle BDP is equal to angle CDP. Why? It is following the exterior angle property. Angle BDP is equal to angle CDP. Angle BDP is equal to angle CDP. So, DP bisects angle D. That is why DP bisects angle D. Okay. Hence, AP bisects, AP bisects angle A as well as angle D. AP bisects angle A, as DP bisects angle D. DP is a part of AP, so AP also bisects angle D. Okay. So, students, let us discuss the fourth bit of the question. Okay. So, we have angle BPA plus angle CPA is equal to 180 degree. Angle BPA plus angle CPA is equal to 180 degree. Which two angles? BPA and CPA. Why they are 180 degree? Because they lie on the same straight line or straight line segment BC. So they are building a linear pair. Linear pair. That means I can substitute CPA by BPA. So if I substitute CPA by BPA, I get angle BPA plus angle BPA is equal to 180 degree. That implies 2 angle BPA is equal to 180 degree, or it implies angle BPA is equal to 180 degree by 2, that is 90 degree. It is 90 degree. Okay. So as BP is equal to CP, okay, we have already proved it that BP is equal to CP, and AP is perpendicular to BC. AP is perpendicular to BC. Why? Because angle BPA is equal to 90 degree. So AP, that implies AP is perpendicular to BC. Okay, we have already proved, because the angle is 90 degrees, so AP is perpendicular to BC, and we have also proved that BP is equal to PC. So that implies AP is perpendicular bisector of BC. Okay. So we have completed question number 1. Hope you have understood. So students, with this we have come to the end of this session. In this session we have learned some concepts about the congruency of triangle. We have gone through some questions of the exercise. In our next session we will complete the exercise and learn some more concepts about the triangles. Till then, keep practicing, keep smiling, be safe, be healthy. Okay? Thank you.